Hi everyone, welcome to Anu's classroom. We are continuing our discussion on the term and examination numerical questions from MMPC 5. Like I've said in all the other previous videos, if you are short of time and if you are not very comfortable with numericals, don't attempt to learn numericals in the last moment. But if you have time or if you really want to explore at least whatever questions have come up in the past term and examination questions, please look at all the videos that there are regarding the term and examination numericals. I have uploaded it as parts wherein we will be focusing on one particular topic and its numericals from the previous year question paper. So this is one such video where our focus will be on questions from normal distributions. So normal distributions, what are they? Normal distributions are a very important part of statistics. The reason being it models many of the natural phenomena that we see around us, like our traits, like the human traits, the measurement of errors, and a lot of other things. As a manager, we will have to calculate probabilities, make predictions, and even understand data patterns, which can easily be done if we assume or if we can map that data to a normal distribution. If I have to say a very common scenario that every manager have to go through, every employee has to go through is the appraisal period, right? We are all aware, if you guys are working, then you will know. If anybody in your near to you is working, you will know that every year or sometimes even twice a year, 4 times a year and all, we'll have to go through an appraisal, right? A rating will be given for every employee. So during these appraisals, we as managers are told, mostly the instruction from the higher ups will be that we have to make the ratings to follow a normal distribution. That is, we cannot have all top performers. There should be you have to note down, or you have to highlight the top cream performers, the moderate, the average guys, and the low performers. It should be like that. We cannot have a lot of high performers. High performers number should be limited. A little more than that, we can have the average guys, and again very few underachievers. Like that, the distribution has to be made. So many times, since we have to adhere to this normal distribution, right? We'll be asked to modify ratings to fit this bell curve. So what will happen is that if you guys are on the borderline between high achievers and meets expectation, you will be pushed down to meets expectation, right? So what happens is that it's a very sad part of being a manager. Actually, you might have to modify ratings, leading to, like, you might want to give your your employee, your subordinate, that extra push by giving them a good rating, but unfortunately you will not be able to do that. Sometimes it happens. So it is not very as simple as just these things. There are a lot of other metrics involved. I'm not going into detail on that because it depends upon the conditions, the market conditions, the number of people in your team, and all those budgets, and all those many things, which you will get to know once you reach that managerial stage. So but what I want you to understand is that this normal distribution, this concept of normal distribution, is a very important one for managers, right? So a normal distribution, you must understand this thoroughly in MMPC 5. This normal distributions, all its properties, how to handle them, all these things you need to know. So a normal distribution is a bell-shaped curve which describes how data is spread around an average. Average meaning mean, okay? Most values will be near the mean. A fewer ones will be far away, and it helps. This normal distribution helps us in calculating probabilities, in making predictions, and understanding data patterns using something called as the z-score. This z-score will be used to compare data points and find probabilities using a standard normal table called as the z-score table, or z-area table, z-table, right? Not c. Okay, I'm saying z. Some people say it as z-score. Okay, this is what I'm saying. Okay, so MMPC 5 term and examination have also had numerical questions from this particular topic in the past. So let us get our hands dirty by looking at how these questions are and how we can tackle them. So the first question that we'll be tackling today asks us to find the number of soldiers in a regiment of 1,000 whom we are expecting to be over 6 feet tall. Now the mean height of the soldiers is given as 68.22 inches with a variance of 10.8 inches. So To solve this question, we have to convert the height of the soldiers in this regiment to a corresponding z-score value. The formula to convert whatever is given to us into a corresponding z-score is z-score is equal to x minus mu divided by sigma. So we know what is mu. Mu is nothing but the mean. Sigma is nothing but the standard deviation. How to find standard deviation? We are given the variance. Standard deviation is root of variance, right? Simply you take the square root of the variance, we will get the standard deviation. Now the question is, what is x? If we know x only, we will be able to substitute all the values and find out the z-score. So the height threshold or x value over here is 6 feet. Why? Because we are told to find out how many people or how many soldiers in this particular regiment of 1,000 people are expected to be over 6 feet tall, right? Over 6 feet tall. So x is 6 feet. Not just 6, it is 6 feet. Now you need to have, we have to, before we can get to substituting the values in this equation, we have to convert all of these values, data points, into a common unit. Because x is given in feet, mu and sigma, sigma square specifically are given in inches. So what is 1 feet? 1 feet is nothing but 12 inches. So we have to convert 6 feet into corresponding number of inches. By going by this formula that 1 feet is equal to 12 inches, we will get that 6 feet is more or less 72 inches. So the mean is given. Standard deviation we can find out as the square root of variance. X we have. So we have all the values. We can substitute in this formula. It's a very simple subtraction division case only. So you do the calculations on your own and you check if we got the same answer. So I got the z-score value as 1.15 approximately. So this is the z-score value. The answer doesn't end here. To find the number of soldiers who could be over 6 feet tall, we have to find the area beyond the z-score, right? Z-score indicates the number of people who would be 6 feet tall. So more than 6 feet tall means it will be more than the out of that, like more beyond the z-score. Now the total area, if we are assuming a normal distribution, if you find out the total area inside this bell curve, it is assumed to be 1. So you divide it in exactly half, means each half of the bell curve will have an area of 0.5 each, right? So that means between 0 and plus 1, it will be 0.5. Between 0 and minus 1 also, you will have an area of 0.5. So now we are given the area between 0 and 1.15, right? The Z table area between 0 and 1.15 is given in the question as 0.3749, right? So so we are assuming, let us assume that this 1.15 falls somewhere over here, okay? So if the area between 0 and 1 is 0.5 and the area between 0 and this 1.15 is 3.3749, the area outside of that will be 0.5 minus 0.3749, right? So that will come around 0.1251, it will come, okay? So that is the area, z-score area, okay? Now we are asked about a regiment of 1,000 people. So you multiply this 0.1251 which we got with 1,000, the number of soldiers in the regiment. So we will get 125. 0.1 you ignore, right? 125 soldiers. So in a regiment of 1,000, we are expecting that 125 soldiers will be over 6 feet tall, right? Understood? So I hope you understood how you can solve it. If you I am going by the assumption that you know how to figure out the area and all those things. I'm just giving you an overall picture on how you can put this into action, right? I hope you did understand how you can solve such a question here. Please make sure you do the calculations yourself. Confirm if whatever I have given you is right, because in that way you will understand if you are actually clear about the concept or do you feel like there is any gap. Because when you hear somebody solving the question, it will feel all very easy until you try to solve it your own without any particular help, right? So pause the video, look at the question a lot, okay, and try to solve this yourself. And if you are not getting the concept, or if you are not able to understand how it went from one step to the next, let us know in the comment section. Either me or somebody from our community will surely help you out, right? So before we before you particularly jump into the next question, make sure you're thorough with this particular question, because this is a very simple, straightforward question. The next question may not be as straightforward, right? So I hope you paused the video, you made yourself clear on how to handle the first type of question, which is one of the, what you can say, easiest types of z-score problems. Now let us look at a little bit more complex z-score problem. So the next question that you can see on the screen is much more closer to a real life scenario that a manager would have to handle. Okay, this particular question is having two parts. We are told of a company which manufactures batteries, and this company guarantees those batteries an average life of 24 months. Sorry, a life of 24 months. The average life of the battery is found to be 33 months with a standard deviation of 4 months. Even though they have found that the average life is 33 months, they are guaranteeing only 24 months, right? So note here, we are told to assume it is a normal distribution, and we are asked to check how many batteries will have to be replaced under the guarantee period. If you are giving a guarantee of 24 months, means within 24 months, if the battery fails, you will have to replace it. So that is the first part of the question. Let's see how to solve the first part of the question before we go on to the second part. Okay, so we have the mean and the standard deviation given. Mean is 33 months, standard deviation is 4 months. So what we have to find out? We have to find if the battery will fail in less than 24 months. So x is 24. So we have the value of x, mu and sigma. Put it in the z-score equation. You will find out the z-score. What is the z-score? The z-score, whatever z-score you get, write it down, okay, and see if we are getting the same thing, right? For me, I got the z-score as minus 2.25, okay. But unfortunately over here, we are not given the z-table area. If you are lucky, invigilators may give it, but we may not always be very lucky, right? We may not always be very lucky about whether either the invigilators give you the z area, like in the first question, even though it is not in the term and examination. Sometimes they do announce the value that you have to use. Sometimes they may not. So to be on the safer side, you go prepared with a z-table area for your term and examination, okay. So you will get it as a very small booklet, a very few pages only, from any store which sells college books and all. Or what I can do is I'll leave a link to a PDF version of the same thing in the description box. It is just 2 pages only. You can take a printout of it and keep it with you. Or else, like if you know anybody from the science stream, even in 11th and 12th standard guys also, they are fine, engineering guys, whoever, you can ask them. They will have the statistics and probability booklet. They will have, in that there will be z-score table. You can lend it from them for your term and examination. So I am assuming you know how to use that table, okay. If you don't, then let's see if let me know in the comments. I'll see if we can have a separate video on how to get the data from the z-score table. Anyway, in this video I am not going in detail on how to use that table. I'm assuming you know it. So using the z-table, we can calculate the cumulative probability that is corresponding to this z-score value of minus 2.25, okay. And that comes to be around 0.0122. Okay, you convert it into percentage, it comes to be around 12. So 1.22 percentage. So we can expect that 1.22% of the batteries that they are producing could be expected to fail before 24 months. So that was the first part of our question. Now the second part of the question is a application of whatever we figured out in the first part, okay. So the answer to the first part of the question is 1.22%. Now coming to the second question, we are given the annual sales of the company. It is 10,000 batteries. So we have to find out the net profit for this annual sale of 10,000 batteries. We are said that each battery sold will give them a profit of 50 rupees Whereas if one battery comes for replacement, then they will lose 100 rupees. So from the first part, we know we can expect 1.22% batteries to get replaced. So an annual sale of 10,000 batteries means 1, 2, 3, 4, 5. So that will come around. How many batteries you can expect to be replaced? 12,200 batteries you can expect to be replaced. So now 10,000 batteries are sold. Each battery will give a 50 rupee profit, means we can get from sales, we can get 5 lakh profit. Now 12,200 batteries could come for replacement. Each replacement will lose them 100 rupees, means we can expect how many like total replacement cost to be. What will be the total replacement cost? Sorry, did I do my calculation wrong? If it is 0.122, so 1, 2, 3, 4, right? Sorry, my bad. Not 12,200 batteries, obviously, right? Oh my god, I'm so stupid. There are only 10,000 batteries getting sold, right? How can it be 12,200? My bad, my bad. 122 batteries will get replaced. So 122 batteries replacement cost will be 12,200. See, things like this happen. So, but make sure you catch it, right? Make sure you recheck and catch it. So, from sales, we will get 5 lakh rupees, but for replacement, we will lose 12,200. So, you minus 12,200 from this sales cost and you will get 4,87,800 rupees. So, the net profit that you can expect from this particular thing is 4,87,800 rupees per year or annually. So now you can conclude your answer by writing down that the number of batteries to be replaced in a particular year would be 122 out of 10,000 batteries, and the net profit for the sale of 10,000 batteries annually will be 4,87,800 rupees. So there you have it. That is how you can tackle this kind of question if it ever comes in your term and examination. But make sure you make sure that your calculations are right. Double check your calculation, correlate it with the like the metrics, the numbers that are given in your question. Make sure it is a reasonable answer, right? So as we do in all our previous videos also, let us see how to identify when you see a question, if you have to apply this normal distribution formula, whether you have to go for the z-score and things like that. How can you identify? That is the most important part of it, especially if you are trying to learn this term and examination numericals in a time crunch. So to identify whether it is a normal distribution probability problem or not, we have to look for certain characteristics in the data that is given to us. The first is definitely see if there is any reference to a normal distribution. Like, is the problem providing a mean or a variance or standard deviation, and is it mentioning that it is going to be a normal distribution explicitly, or whether it is assuming that the data is going to be normally distributed like that. If there is any reference to a normal distribution, definitely it is a normal distribution problem. Similarly, is it asking us for any threshold based probability, like asking us to figure out the proportion or a percentage or count of items or individuals above or below a particular value, something like that, something like that is given, then also it is a normal distribution problem. Similarly, does it involve calculating probabilities and then scaling them to a given population size, like in the soldier situation or even in the battery situation, right? We were asked to calculate a certain probability and then we were asked to scale it up to a regiment of 1,000 soldiers or an annual sale of 10,000 batteries. So you're scaling a particular, you're finding something and you're scaling it up to the population, to a given population. Then also you have to use normal distribution. Similarly, if a problem requires us to convert raw values into a z-score, or if we have to consult a z-table, then again it is a normal distribution problem. So make sure you look out for these characteristics if you are having difficulty in identifying if a new question comes in the your term and examination. Not unlike the questions which we have discussed in this video, if a new question comes and you are finding it difficult to identify, look out for these characteristics and you will be able to identify if it is a normal distribution or not. So make sure once you identify, make sure that you are memorizing the formula for the C score so that you can use it in calculating your answer. Again, as I say in every video, all these things will become like second nature to you only if you practice enough. Okay, so don't worry too much. Even if you are not very great in numericals also, if you are strong in your theory part, if you are going prepared well enough for with the theory, also you will pass. So don't worry about passing. I hope your confidence level in solving numerical questions have increased after this video. We will meet again in the next video where we will be looking at some more types of numerical questions which have come up in the past term and examinations, so that you will be prepared to face them if they ever show up in your term and examination. Thank you very much. Happy learning.